Hello guys and welcome to Mossy Maths. Today we're going through the third lesson on the topic of circles and we're looking at the properties of circles. Now this will develop our understanding from lesson 2 where we looked at circle equations, and it will complete the topic of circles. So after this we'll be moving on to simultaneous equations, which will be the final topic of Core 1AS Maths. So with this topic of circles we're going to go through 3 exam style questions taken from the latest AQA revision guide. And the first question has a part A and B. You'll notice also that these 2 questions have diagrams. It's not necessarily the case that in an exam you're going to be given a diagram. Such as in this case, you might have to imagine what's going on. So let's get started with the first question. The point A, 6, 4, lies on a circle, x squared plus y squared, minus 4x minus 2y, minus 20 is 0. And we have to A, find the centre and radius of the circle, and B, find the equation of the tangent at A. So let's start with part A. Find the centre and radius of the circle. Now, if you've watched my previous video, you should be aware of how we do this. We simply have to complete the square with this to get the circle equation in the form x minus a squared plus y minus b squared equals r squared. And that way we can identify the centre and radius of the circle more easily. So, we consider the x's first, then the y's. If you're not sure how to do this, do look at my previous video. So I'm going to go through this quite quickly, as we've already gone through this. So, we halve the coefficient of x, minus 4 becomes minus 2. We square it. When we expand the brackets, we get a positive 4. And we don't have a constant term when we consider the x squared minus 4x. So we have to minus that 4 that we get. And this is now the same as x squared minus 4x. Considering the y's, we get minus 1 when we halve minus 2. We square it. When we expand the brackets, we get minus 1 times minus 1, which is positive 1, so we subtract that. Now we rewrite this in the form we've just created. X minus 2 squared minus 4 plus y minus 1 squared minus 1, and don't forget the minus 20 from the question, equals 0. And now finally, we can put the bits in brackets together, like this, and we collect the constant terms. We have minus 4 minus 1 minus 20. Well, minus 4 minus 1 is minus 5, minus 5 minus 20 is minus 25. So we could write minus 25 equals 0. However, I'm going to jump a step, just for the sake of saving space. I'm going to move the minus 25 across, and it's going to become a positive 25. And you'll notice that this is now in the form we need it. X minus a squared plus y minus b squared equals r squared. So we can identify the centre, which I'm going to call C. The centre is just the opposite of the sign we have in each bracket. So the x coordinate is just going to be, we swap the sign, it's going to become positive 2. And the y coordinate is going to become positive 1, flipping the sign again. So we get 2, 1 as our centre. We now need to consider our radius. Well, if this is our r squared, our radius squared, then our radius is going to be the square root of 25. We just square root both sides. And the square root of 25 is 5 and minus 5. Now, the thing to remember is we're going to get both a positive 5 and a negative 5. However, we don't take the negative 5 answer. The reason for this is because we're asked for a radius. Now a radius is just a distance, and we can't have a negative distance. So we just take the positive answer for our radius. So we now have a centre and radius. We've answered part A, and that could be worth 2 or 3 marks. Possibly even 4 for the fact we're rearranging this. And part B says find the equation of the tangent at A. So there's a few things we need to identify. The first thing is the word tangent. So what does this mean? Now, if you're not sure, do go back to my section on coordinate geometry, where we did define what a tangent was. It's just a line that touches a point at that point only, and it won't touch it again. So, for example, if we look at, say, this circle here, if we looked at the point B, then the tangent would be a line that goes like this. It doesn't touch the circle at any other point but B. And it only touches B once. Okay? So it will be a line like this. So it's important we remember what one is, and we're looking for a tangent at A. And we're told A is a point 64 that lies on the circle. And that's important, the fact that it lies on the circle. So, what we need to do is look at the coordinates we have. We have 6, 4, and we also have the centre, which we've just calculated, 2, 1. So if we have the centre of a circle and a point that lies on a circle, then we have a radius. The radius is just the distance from the centre to the edge of the circle. So we have a radius line, a line that goes from the centre to the circumference. And the tangent at the point on the circumference, so say we pick this question here, we pick this point, a tangent will be a line that goes like this, and the radius line will go like this. And as you can see, those two lines are perpendicular. They're at right angles to each other. A line that goes like this and a line that goes like this are at right angles. Therefore, if we're finding the equation of a tangent, we know that the gradient is going to be the negative reciprocal of the gradient of the line with the radius, the line going from the centre to the circumference. It's going to be the negative reciprocal of that. So if we find the gradient of the line that goes from the centre to the point on the circumference A, then we just do y2 minus y1 divided by x2 minus x1. We do 4 minus 1, which is 3, divided by 6 minus 2, which is 4. So 3/4 is our m, our gradient. So the gradient of the tangent is going to be the negative reciprocal of this, because it's at right angles to that line we've just found. So we simply flip the fraction over and we change the sign. Well, this is a positive, so it becomes a negative, and the 3 divided by 4 becomes 4 divided by 3. We flip the fraction over. And this is our new gradient. So now we can see where this is going, because it's at the point A and we have a gradient. So we need to use the equation y minus y1 equals m times x minus x1. And that equation we covered in the section on coordinate geometry and a bit on differentiation as well. So if you're not sure about that equation, do go back to those videos where we looked at it. It's just a development from y equals mx plus c, and it's the equation we need to know at AS level. So if we use that equation, y minus our y1, well, that's the value of y given to us at the point A, 4, equals our gradient, which we've just calculated to be minus 4/3, times x minus our x1, which is 6. Okay? So we get y minus 4 equals minus 4/3 x. Now minus 6 times minus 4/3, well, it's going to become a positive. 6 times 4 is 24 thirds. Okay? Now 24 thirds is actually just going to be 8. Okay? 24 divided by 3 is 8. So we can say that y equals minus 4/3 x. Now this is just 8, and this minus 4 will become a positive 4. 8 plus the 4 is 12. So we could leave it in this form, and we would pick up full marks. However, in my opinion, it's always worth simplifying it fully. And by doing that, we multiply everything by 3, because we have 4/3, we have a fraction, and I would prefer to have integers, whole numbers. So if we multiply the whole thing by 3, we get 3y equals minus 4x plus 36. Okay? So all we've done is we've changed y equals minus 4/3 x plus 12 into a form where we have integer values. 3y equals minus 4x plus 36. So there's the answer to the first question. Now let's move on to the second question. The circle below, with centre C, has points A and B that lie on it. So the A and B are on the circumference of the circle. And the midpoint, M, of AB, is the point 4, 4. B is at the point 6, 3. And line L passes through C and M. So this is the line L, okay? Passing through C, the centre, and M, the midpoint of AB. This is L. And we're told to find the equation of this line L. Find its equation. we have to find the equation of the line L going through C and M. So the way I would automatically start this question is to think, well, we have the points M and B, which is part of the line AB. Okay? M and B are part of this line. So, we can find the gradient of the line AB because M is a point on AB. So if we consider the coordinates of M and B and find the gradient using y2 minus y1 divided by x2 minus x1. So we get y2, which is 3, minus 4 is minus 1. 3 minus 4 is minus 1, divided by x2 minus x1. 2. 6 minus 4. And this is the gradient of AB. Now, as you can see, if M also goes through the line L, then the line AB and the line L are perpendicular to each other, okay? So, this means that we can simply take the negative reciprocal of this gradient, and that will give us the gradient of the line L, because this, AB, is perpendicular to L. So if this is the perpendicular gradient, then the gradient of L is a negative reciprocal of minus 1 over 2. So we change the sign so it becomes positive, and we flip the fraction, 2 over 1, which is 2. So we get positive 2 as our gradient. And now we can see what we have to do to find the equation of L. We have a gradient, and we have a coordinate of a point that goes through L, M. M goes through L as well. So we can use the coordinates of M and our gradient in the equation that we used for this question here to find the equation of the line L. So y minus our y1, 4, equals our new gradient we found, 2, times x minus our x1, which is 4. So expanding this, we get y minus 4 equals 2x, minus 4 times 2 is minus 8. And then we get y equals 2x. Now minus 8 is going to become plus 4. Okay, moving that across, which is going to give us minus 4. So y equals 2x minus 4 is the equation of L. So that's all we're doing. We're using this equation here, y minus y1 equals m times x minus x1, and we're substituting in the point M, because that goes through L, and we have the gradient by taking the negative reciprocal of the gradient of the line MB, or AB, which is perpendicular. Okay? Now finally let's go through the third question, which says the point A, minus 2, 4, and B, n minus 2, and C, 5, 5, all lie on the circle below. AB is the diameter, and we have to show that n equals 6. So we're showing that n equals 6. That means we're proving. And when we're proving, we have to show each line of working. We have to show every step of the question and how we answer it. So, the first thing we can do is we have the coordinates of A and C. So if we find the gradient of AC, we know that that's going to be perpendicular to the line CB, okay? Because this is a semicircle, and we should know, using the properties of a circle, which we should have gone through at GCSE level, then in a semicircle, okay, we have a 90-degree angle, which is here. That means that the line AC and BC are perpendicular to each other. So if we find the gradient of AC, then we can take the negative reciprocal of that gradient to get the gradient of BC. So y2 minus y1 divided by x2 minus x1, it's the same thing. So we do y2 minus y1, 5 minus 4, which is 1, divided by 5 minus minus 2. 5 minus minus 2 is 5 plus 2, which is 7. Take the negative reciprocal of this to get the gradient of CB. We get, flipping the fraction, minus 7 over 1, which is minus 7, when we take the negative reciprocal. So our gradient is minus 7 for the line CB. We have a gradient, okay, and we have the point C, which is on this line. C is on the line CB, of course. So, if we have a gradient and a coordinate of a point going through the line, we can then calculate the equation of the line CB. Y minus y1, y1 is 5, equals our gradient minus 7 times x minus our x1, 5. So we get y minus 5 equals minus 7 times x is minus 7x, minus 7 times minus 5 is positive 35. So moving the minus 5 across, we get y equals minus 7x, 35 is going to be plus 5 is plus 40. Okay, so here's the equation of the line CB, but we need to show that n equals 6, and n is the x-coordinate of the point B. Now this is why we found the equation of the line CB, because we have the y-coordinate of B. So all we need to do now is, knowing that B goes through the line CB, now we can simply substitute in our y value of B, which is minus 2, into this equation, and we can rearrange it to find our x value, okay? So our y value is minus 2, so if we change y and replace it with minus 2, equals minus 7 times x plus 40. Now what I'm going to do to show we're proving that n equals 6, because n is our x-coordinate of B, I'm going to replace the x in this equation with n, just to show we're proving n equals 6. So minus 2 equals minus 7n plus 40. Now we can minus the 40 from minus 2, and we get minus 40 minus 2, that's minus 42, equals minus 7n. We swap the signs for both, we can do that because we have two negatives, so we can get 42 equals 7n. So 42 divided by 7 equals n. 42 divided by 7, well that's 6. So n equals 6. We've now proved it, okay? So what we've done is we found the negative reciprocal of the gradient of AC to give us the gradient of CB. We've then substituted in the coordinate C and the gradient we found to find the equation of the line CB. We know that the point B goes through the line CB, so we can replace y with the y value of B, which is minus 2. And we can then rearrange it to find our x value, which in this case is given the letter n. So we replaced x with n to show that we were proving n equals 6. So there we go, guys, that's the last topic on circles, the last lesson on the topic of circles, and in the next lesson we'll be going through simultaneous equations, which is the final topic of Core 1 AS Maths, and then I'll be moving on to Core 2. So if you found the video helpful, please put a like. If you do have any questions, leave a comment and I'll get back to you as soon as I can with an answer. So thanks a lot, and I'll see you in the next lesson.